we have CR high pass filter here, and our task is to find a gain at 1 kilohertz frequency as a function of resistance. So we have a fixed frequency of 1 kilohertz, we have a fixed value of this capacitance. We are changing this resistance. At first we obtain this curve, and by means of PSpice simulation, and then we are looking for the level of 0.7071, which is the gain at cutoff frequency, and we will find that this gain, our resistance, is 159 kilo ohm. So this is a version based on manual netlist. This is a version based on schematics. Netlist created automatically. Here we have analysis setup, AC sweep, 1 kilohertz, single frequency, and then variable resistance, decade sweep type from 10 to 99K with 100 points per decade. Okay, this is the result, and we have exactly the same curve as before, and well, there is no difference between probe windows. Doesn't matter whether we are using schematics version or not. Now, very same circuit, a high pass filter, and nearly the same problem, sizing of R such that the cutoff frequency is 1 kilohertz. However, at first we want to sketch a cutoff frequency as a function of R. Cutoff frequency as a function of R. Then, having this plot, we may find the resistance, looking for the level of 1K on this curve, and obviously it will be 159K. On this slide we have a manual netlist version. Schematics version is here, so everything is the same except that we now have AC sweep, not single frequency. We have the frequencies changing from 10 to 20K with 100 points per decade. And we may start simulation. When simulation is completed, please observe that on horizontal axis we have a frequency originally. We have to change to a resistance. We have to select performance analysis by clicking this icon, and then we have to add trace, and from available traces we may select a available goal functions. We may select this function, which is x at nth y. X means resistance, y means gain at 1K 1K frequency. So this is a gain, and this is a variable, and this is the gain. Same exemplary problem, but slightly different task. High pass filter, but now our task is to sketch the cutoff frequency in terms of resistance, and then to size resistance such that the cutoff frequency is 1 kilohertz, the same as before, which means that obviously our result is 159K. So this slide presents manual version of a netlist. We have a curve, a function of gain, cutoff frequency gain. This is gain at cutoff frequency. This unity is meaningless. I'm not going to explain. It has to be there. And then we are searching for the level of 1K, and for this level we obtain here that the resistance is 159K. This is a schematic version of the same. We have now perform analysis sweep, AC sweep, from 10 Hertz to 20 kilohertz with 100 points per decade. Then when simulation is completed, we have a probe window, and on the horizontal axis initially we have a frequency. It is AC sweep. To replace frequency by resistance, we have to select performance analysis. We have to click here, and then this frequency is replaced by resistance. Then we may add trace, and we may select a goal function. Our goal function is a function x at nth n is 1 and y. So our y is voltage across the resistance. Our gain is, well, gain the cutoff frequency, gain 0.7071. So this is the same curve, and tracing this curve for the level of 1K, we obtain our resistance. Okay, and this completes this exemplary problem, or actually two problems.